Lesson 5-2, Angle bisectors and perpendicular bisectors. On the front you have a vocab sheet. Let's fill in our two new vocab words today. Perpendicular bisector is a line, segment, or ray that divides a segment into two equal parts and is perpendicular to the segment. So if I were to sketch a perpendicular bisector of AC, I would sketch the midpoint, marking that my midpoint D happens. And then I would draw a perpendicular line, making sure that it goes through at 90. So I'm just going to nudge this over a little bit. So like I said, it forms a midpoint and it also forms a right angle. That is a perpendicular bisector. Here's a specific example without a triangle involved, where it meets at a 90-degree angle and then it bisects a segment. An angle bisector is a line, segment, or ray that divides an angle into two equal parts. So if I were to draw an angle bisector of angle A, it would just split the two angles equal. Angle B, it would split the two angles equally. And angle C, it would split the two angles equally. So down on the bottom, here's an example of just an angle that has a ray bisecting that angle. So then P and Q, the measures of those smaller angles would be equal. So perpendicular bisectors. We're on page 6. Perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So I started out with some segment. If I pick a point that is on the perpendicular bisector, that would tell me that the distances from that point to the end point, from the point to the other end point, would be congruent. So notice this does say congruent. The converse of that says, if I have that segment on the bottom and I'm on a line that touches it such that AC and CB are congruent, that means that this line CD is perpendicular and it's on a bisector. And notice how if I shade in half of that picture, it turns into a triangle that has hypotenuse and leg congruent on the other side. And that's why all this stuff is working. So let's do some questions. Question number 1, find the value of x. So we have a segment that has a perpendicular bisector on it. We have the marking for a midpoint and we have the marking for a right angle. So what we know is if we pick a point on that bisector, it's going to be equidistant to each endpoint. So 7x plus 24 is equal to 13x minus 48. So I'm going to subtract 7 from both sides, 7x, and that gives me a 6x. I'm going to add 48 to both sides, and that gives me 72. Dividing by 6, I get x equals 12, and I tend to just write it x equals 12 in this manner. Number 2. In this case, I think we're looking at the converse. So we have a segment here, and we have a line that touches that segment. If we pick a point on that line and it is equidistant to both endpoints, and it is equal, that means that that line was a perpendicular bisector. So our equation is that they are equal. So getting our letters together, subtracting the 9x, adding the 3 gets us to 8x equals 16. Dividing by 8, our answer is 2. Question 3. We're on a segment and we're at the perpendicular bisector. So then point R is equidistant to Q and it is equidistant to S. Solving the algebra equation, minus 4x, and we get 3. want to get my numbers together, so I'm going to add 22, and I get 27. Dividing, and we get 9. Pay attention to the question, though. It's asking for the length from R to S. So I have a step of work to do. I know that X is 9. So on my calculator, 4 times 9 plus 5, or in your head, you're getting 41. Number 4, we have a line. We have another line intersecting it at what looks to be a 90-degree angle. We can double check that if we pick a point and see that it's equidistant to both of those vertices. So then we know that this is a perpendicular bisector, so those segments are the same. So we're going to subtract 2 and get 12x, add 37. 48 equals 12x. I like to do my adding and subtracting so that my x value is positive. So that's why I didn't subtract 14x. Subtract 14x to get a negative 12. And then the last step was to divide by 12. Looking at the question, we needed to find EG. So we need to plug in 2 times 4 plus 11 gives us 19. Try the next 2 questions. Pause the video till you're ready to see the answers. Number 5. The segment that we're given is AB. It looks like C is on the perpendicular bisector. To know for sure, we need to know that it is equidistant to each of the endpoints, which it is. So what we can say is that those 2 expressions are equal, solving for x. The question is asking us for AB. Well, instead of adding those together and getting 8x plus 6 and then plugging in, I'm just going to find half of it and then double that number. So plugging in for 5x minus 11, I get 59, and that happens on both of those parts. So 2 59s gives me 118. Otherwise, 8 times 14 plus 6 will also give you 118. Question 6 is set up in the same way. We know it's a perpendicular bisector, so any point on that perpendicular bisector is going to be equidistant to the endpoints. So when we solve for x, we get 20. The unknown is going to be jk. So 6 times 20 minus 26 for 94. The next topic is angle bisectors. So if we start out with an angle AB, and we have an angle bisector, that bisector is equidistant from both of those rays on that angle. So then this length would be the same as this length. The converse of that says if we have an angle and we have a point somewhere on the interior of that angle that is equidistant, then that line that it is on is the angle bisector. So looking at question number 1, here is the angle highlighted in red. It looks like we have an angle bisector. So then any point on that bisector is going to be equidistant to that angle. So we get 4x plus 30 equals 9x minus 5. Getting our letters together, getting our numbers together, we get 7. So if I were to pick another point on that angle bisector and I drew distances perpendicular to the edge, those two would also be congruent in length. If I went here and went perpendicular, and I went here and went perpendicular, those two lengths would be the same. So that is what the angle bisector theorem is saying. The converse says that if we pick a point on the interior of an angle and it is equidistant, then we have some angle bisectors. So 5x minus 11 equals 8x minus 41. Getting our letters together, I'm going to subtract 5x and add 41. So x is equal to 10. Number 3, the angle is highlighted. It looks like we have an angle bisector, so then the distances perpendicular to the angles would have to be congruent. Go ahead and solve that for x. And our algebra tells us that x is equal to 3. But now we have to plug in for AD. So AD is from here to here. So we're plugging in for the 13 minus 4. And it looks like I plugged in on the other side. But we know those distances are the same. I just thought a coefficient of 8 times 3 I could do in my head and add 11 instead of 8 times 13. I would have maybe needed my calculator. Number 4, we have an angle. We have a point on the interior of an angle that is equidistant to each of the sides. By the converse, we know those angles have to be the same. So solving for x, we get 7. And we are trying to find angle XWZ. So half of that entire angle. Again, I chose to use the 3x plus 3 because those numbers were smaller, easier to do in my head. Both angles would be the same. Try these last two problems. Notice the angle that I highlighted is what we start with. When you're ready to see the answer, unpause the video. This concludes my lesson. Thanks for watching. Have a happy holiday.